Hello and welcome back to Google.rs. It's Byron speaking. And yes, this is definitely, I was just looking at my system resource usage and I realized, okay, when I record stuff using QuickTime and it can't use the graphics card because Final Cut is rendering something, then it will use the CPU, which is terrible. Using 4 cores right away, now it uses 30% CPU. So that's actually interesting to know. But I changed my workflow to actually offload the final cutting to another machine. That is slower, but should work. Anyway, that's none of your concerns because we are about to deal with issue 115. It's a research ticket that ideally just lasts for one session here. I will have to find my way through this because the actual idea here in this milestone is to provide configuration. Right now, the only configuration we really have, let's say YouTube 3, is this. We can specify config dir where it drops its secrets and authentication tokens, but that's nothing you would usually edit as a user unless you want to have your own quota for your own application, because the applications I provide, they run on my own projects basically, which means they have a shared quota. If 1 million people would use this, the quota would probably be used up relatively quickly, and then you want to set up your own project on the Google Developer Console to just get your own quota and drop it there, and it will be picked up. That's kind of the main idea. What I'm talking about is this. So if you go to Google Service CLI configuration, then you could have a look at YouTube. And the secret is something that I can show. It's not that secret from that point of view because it's really something I distribute publicly. And this is basically what you get from the Google Developer Console, and you want to get your own in case the quota is depleted for the application ID that I come with, that I ship with. But that's nothing that I want to change because that's actually pretty cool. Also the way tokens are handled, it's a little JSON-based token database. If you want to kill the tokens, you can just, basically make it forget the tokens. You can, of course, remove the grant, then it will remove the file itself next time it tries to use it. Or you just kill the tokens locally, which probably isn't so advisable, and then it will ask for a new grant. Anyway, but that shouldn't be it, because what's really interesting, what's really important here is the delegate, or actually the original goal that seems to have been lost in the meanwhile, which is to have a super resilient uploader. And resilience means that it can retry stuff. And retry loops are built in everywhere. This means if something fails for some reason, a delegate is asked to be told what you would like to do. Right? And right now, the default delegate is used, which does nothing, which aborts, which is very conservatively implemented to basically just not be in the way and not make any assumptions. So by default, things will abort. And that's really it. Also, resumable uploads are not supported because these functions here need to be implemented to do something, or these methods need to be implemented to do something to support that. And right now, there is no way to do that. Also, the delegate is called when things happen. This can be used for progress, for instance. You know if something finished successfully or not, which will also allow you to automate stuff. So you could say, well, the upload succeeded, so I will remove or move the files that have been uploaded somewhere else. Something like that you can easily do. And in the moment you begin something, well, I'm just looking at this, how useful it can be, because something that seems unfortunate is that the delegate will not, or is not able to learn about the request. It just has a method info, which provides a little bit of information. And that can probably be extended. Yeah, that's why I made it, so that I can extend it and maybe even provide request information. But right now I don't have any of this. It would be interesting to see a request value, or maybe have more information about the actual parameters that have been passed to the call, even on delegate level. But let's just say, considering that the CLI makes these calls, I think that's also what I kind of said to myself. We have all the data and can dump it somewhere, or tell our own delegate or give our own delegate additional information. That's just the base implementation after all, the trait for that. And we can have our own implementation that supports more, and then gets more information about the call to be made, like the files that are to be uploaded, which would be interesting for the case when you want to actually work with these files and do something with them. So that said, is the question how it should be implemented. And I will just play around with that to get an idea. So that's kind of, let's just say we want to, as the trait delegate, let's just say we want to, on HTTP error, have a different retry count. How would that work? So I think what I would want to have at first is a configuration file in YAML format per command line program. So it's like YouTube 3 as a prefix, I guess, and then config YAML, like this. So that's my file here. And now I could just go in and define whatever I want to define, structure my data in a way that I find pleasing and that is sufficient to deal with the situation. That's the first thing. So let's just configure this one thing. So we know that this is our own configuration. So we don't need to do much namespacing, right? That's the important thing. So I could say on HTTP error undo HTTP error on HTTP error, and then we can say what we want. We could we get a hyper error, which we could provide to a callback in some way. We could serialize this stuff as JSON. Well, no, actually we can't. The hyper error is nothing that comes with the required implementation, so we had to implement this ourselves even, which is something I'm not particularly interested in. I would like to provide as much information as possible about the respective call, but if it's not possible or if it doesn't really matter, after all, we kind of put that stuff down onto the command line, and if you want to have full control, you would probably implement your own program that has direct access to the API and can have its own delegate, and stuff like that can always be added later as well. So the whole idea is that I would like to be able to configure a retry count. Retry count being, being like 5 maybe. And the delay is something that I'd say I control myself. I could, of course, provide the delay, but I would just implement exponential backoff here, which is recommended anyway. Yeah. So if this is, what can it be? Like if this is unset, if null or unset, we will abort. Yeah, this is kind of how I see that. This is the retry count that you can make. And considering that we can't provide any information, doesn't really, because of the hyper error that we can't really serialize, it doesn't really make any sense to call a program here to do stuff for us, which is something that I generally very much like. But for a begin, for instance, the method info is under our control. We can easily make that serializable. And I'm always about this serializable thing because I'm thinking that we could serialize this as JSON and then provide the JSON data in the environment of the program that we call. That way, we can actually pass along all kinds of information assuming that the JSON data isn't great enough. So let's implement this for begin. So here we have HTTP error, here we have begin, and there's a callback, and we will say that method info is gonna be set method info JSON, or maybe JSON method info is set to a JSON structure with all method information. We could, and I'm totally considering this, we could provide even more information like the parameters, the request structure and stuff like that. Just to have it, but for now I would start with that because it's all about the callback after all. And now it's just a question how you want to do it, how advanced you want to be. Considering that all the information is passed through the environment, we would be good here. Begin can't do anything, so we don't care. So we just say we call a user local bin program. The exit status of the program is discarded. Does not matter, as this call is for your information only, like this. Callback. Yeah, I think, I don't know, is there a better way to call it, like program? I mean, we can rename this at any time, so let's not waste time on naming here. Callback for now is kind of okay. We just say callback is always a program call. And then what else? I would like to have something where the return value matters. And the return value, good, we have an exit status that we should always take as indication for success or failure. And we can return something to std out. And that's where it gets a bit more interesting. For instance, API key call whenever there is a need for your application key after the official authenticator implementation didn't provide one for some reason. If this method returns none as well, the underlying operation will fail. Yeah. So I guess all that matters here is the standard output of the program. And if the program doesn't provide standard output or fails, whatever, I don't think failure will be relevant here. We just consider it a failure if it doesn't provide any output to std out, that is. Well, actually calling other programs is not so super easy, but we will just say std.rs is not supported so that people can't write to that and possibly starve or cause our process to block. Just because they are blocking, then we are blocking while we are trying to read std out, and they're putting everything to std error, then that blocks, and it's a deadlock situation. So we try to prevent that by just taking std out and not opening up any other channel. All right, so where is another, store upload URL? This is probably also something where let's use these because they're for resumable uploads. And then I think we are pretty okay. HTTP failure. There again, I guess I would go with a simple retry count just because the response here is nothing we can serialize, but we can serialize the optional server error if it is there. Yeah, that's something we could do. Provided to the program. But anyway, let's do this first. And then I think I have an understanding of how this should look like. Let's put this to 5. 5 times it should retry if the network doesn't work. And then we go with upload URL. I could call it get upload URL and set upload URL to make it clear. Get upload URL. Could also just have a one-on-one mapping. Yeah, I think one-on-one mapping is more consistent after all. So here we have a program, a callback, user local bin program that will where it will return an upload URL that was previously stored. Write a previously, I don't want to repeat myself, previously stored upload URL to std out. Or not, to indicate there is no such data. So that could be working. And then the store upload URL also has a callback. I really want to keep it like that so that we have the option to kind of provide auto implemented stuff and people know, retry count is there, but not a callback. So, we have options here also when it comes to extension later. So callback, again, some program, and this will be given, that's how it would look like. We will give an argument, given an argument. Yeah. The first argument is the upload URL to store. Wait, how was the signature? Because it can also be not stored. See, it's an optional. So if it is empty, we have received a new upload URL for resumable upload to store it in case we fail or cancel. That way we can attempt to resume. Okay, it will also be called with none after a successful upload, which allows the delegate to forget the URL. That way it will not attempt to resume an upload that has already finished. The problem with that is, I know why I did that, and it's good, generally. But the problem with that is that the delegate doesn't know which URL to forget, because we could as well have multiple invocations at the same time, and then we don't know anymore what the key should be. And that's going to be odd. So the keying is a problem, and I think that was always a problem. Right now it's kind of the same delegate, that is asked for an URL, but returns one, then it has to delete it. But in case of the YouTube uploader, there can very well be multiple of these going on at the same time. And this is kind of dependent on the input or the call arguments that we also have no information about right now. So this is a massive problem when it comes to handling multiple things at once. So that's an issue that we just can't solve right now. There's an API fix that needs to be done. Definitely so. And I'm not sure how. Because we could hash all of our inputs and then have a call ID. The method info could basically have this information. So here we call begin with the method info. And we could also call it later. Let's see when the delegate is called next time. All right, it's always called, as it has to be called early. but we could abort with an error as well. So I guess once we know such an ID, we might actually provide it to the delegate later. You could also build a JSON structure and on an API level provide all that call data that we want. So before making the call, I think there is actually a function for this. Before pre-request, exactly. And this here would be interesting if we had the entire request in some sort of JSON structure that we could then use in the delegate to figure out what to do. We could, for instance, hash it just to get a key and use that key accordingly to know which URL to store and to discard. That's kind of the idea. The delegate is strictly per call, so it is borrowed. Well, right now it is borrowed, but it's not, it's in a, I think it can be in a ref cell or something, but anyway, it's mutably borrowed right now. Is it? Let's see. Delegate, is mutably borrowed. So this means that you cannot have multiple calls to it at the same time, which is good. So we don't run into the errors that even if you have an ID, all of a sudden there are multiple calls, so things get mixed up. This shouldn't be possible thanks to ownership. There's only one writer to something at some point in time, and that's good. That's awesome. Cool. So I think that's something we would want to implement because the CLI needs it. And as I said, yes, we could do it on CLI level, but honestly, the API level has all the information already. And I think if we do it on CLI level, we can as well do it on API level. And there everybody would benefit. So the pre-request, I think that has to be something we deal with. Provide detailed pre-request information about the request in pre-request delegate call. That way, the delegate otherwise has no means to know what exactly he is working on, which also poses a problem for shared delegates. So we kind of have to provide a call ID to every function that we make, so that whatever happens, so that for most of the things that happen, we can provide a, some proper ID, so that it knows what to do and what to associate the data with. This also points and could solve the issue that store URL, store upload URL currently has no means of knowing which URL to discard in case that is desired. So discarding URLs will only happen if you previously returned one, but this also means kind of which operation you're talking about. Right now, we only have kind of one concurrent resumable upload that can happen at a time on the entire system. Right now, with the current API, you can only have one resumable upload in the entire system. Well, that's how that is, which is of course quite annoying. So this is something we wanna fix. And the structure must be flexible enough to keep all the data. So it might want to be a JSON structure that we build. Something along these lines. I like to work with these JSON structures just because it's like a hash map that you can serialize easily without having additional code. This also adds even more dependency to cert, but since we already have it, it's not a problem, I think. And JSON is, right now a good interchange format for programs in general because it's kind of easy to use, And one day we might even implement binary JSON formats and stuff, but for now, that shall suffice. Okay, so that's how that would look like. Right now I can't do more if it's empty. The stored URL should be discarded. Okay, so should be discarded as the upload succeeded. Something like that. So this is how that would look like. And now the question is, how do we deal with it? So there's, let's see what the ticket says, but this is something we now have to read in, actually from YAML, which is a problem because cert doesn't do YAML yet. That's a real problem. We would have to read it in because we are kind of working on JSON structures now. And then, where's the request? I think there's no request structure here. That's discovery. Let's go to groups migration main. Here we might have a structure. No, I think that has an upload. So it's admin email main. So this one has a structure here. And as you can see, right now we have quite neat handling when we get the structural fields on the command line. Pardon. And there's something I would like to have as well for this one. So we don't only read it from the configuration, but we can, on a per call basis, override any configuration value in this config file directly. And this is something that requires us to basically just read the YAML file in which will be the default value, and then we just apply it on top of whatever is the default value. And this is something we have to figure out somehow. There could be a multi-tier way, so we have some YAML dependency, read it in, serialize it to the structure that we want, deserialize it to the structure that we want, then we reserialize it to the JSON value, to the corresponding one. And then we will can have our standard algorithm operating on this, which passes the command line to then finally, and overrides values accordingly. And then finally we can deserialize it back into the actual data structure that we then use in code. Yeah, I think that's how that could be. That's how I would do it. So that would work. But this also means that for this data structure, we need information similar to, if you look at admin email JSON, then we need information similar to this here. The mail item, for instance, this is what you see here. This mail item really wants to be defined like that, because that way we can completely define what kind of structure we desire. With nested types, complex types, everything is possible there, and descriptions, and then automate the serialization and deserialization and command line parsing process similar to what we already do, so we can reuse the same code. So this basically just means that we require additional configuration about this about this config structure here, about the data structure that we want to use. And one way to do it would be to just put it into the CLI here. Here we can just define any kind of data structure and go with it. But on the other hand, that would be kind of convoluted. Why can't we use the existing CLI configuration, which gets loaded in anyway, and then define in YAML what we would otherwise define in in JSON. And JSON is a valid subset of YAML, so if we wanted to, we could actually copy paste this and just put it in here, and this would work. But we of course have to take our own top level key, like CLI. Apparently we don't have a CLI configuration. Config schema. And here we define, you know, the schema like this. So here we go with ID and all this extra stuff. A standard schema as used in API schemas as well as usable, because this means we can use the entire infrastructure and serialize and generate the respective struct in Rust. We can do everything we currently do for the API. We can reuse this in the CLI for this particular config schema, and reuse all the code. And this is it. So at the end, we will have a config schema of some name. We might give it or it has an ID, right? It has an ID anyway. Let's set the ID. ID is configuration. And this will be everything we need, and so on. And then we have this configuration structure in our code, and then we can just implement our delegate. Oh, that's API common. Let's go CLI common. And then we can just implement our delegate with whatever we need. CLI delegate. I don't know what it wants to be, but then we can say, well, do we have access to the API here? Not yet, but I think we can have access to the API. API? No. I think we can use super here. And main Mako. Yeah, because here we are being called, and we could go up and ask for the API. Where do we get it? As API. So basically this thing we should be able to access from here, and then we can use and define the delegate. Use super API. And then possibly we can try that. Let's see. So impl API delegate for CLI delegate. And right now we do nothing. It's default implemented anyway. Let's see how far that brings us. And that could be the infrastructure. And then we can just implement everything we need to implement with the calls and stuff, and have beautiful Rust code in that sense and be happy with it. So that would be the infrastructure that I see for the configuration system. And this kind of brings us very, very close to actually finishing this or being able to fulfill all the requirements for 1.1. So let's see how far we go. Let's compile this. I think it doesn't matter. Discovery is, in theory, at least a very quick one. So discovery, we didn't change anything there. We'll rebuild anyway. Oh, yeah, let's build the CLI, shall we? Now we'll rebuild the API anyway. Awesome, thank you very much, Cargo. Very keen to build stuff nowadays. All right, and now you'll see if we get the API or not from CMN. So far it looks good. I think it would fail. It could still fail because the delegate is not implemented or something. But apparently, let's look it up. Let's be sure. We are in discovery, CLI, common. So this is the latest version. This has changed. We have this stuff here, and it compiled. Awesome. Yeah, so that is the infrastructure that we desire. This is just a sample that, of course, will now have to be converted into the respective schema. I think that's the next thing to do. And then we have to start operating on that and try to just bring it in. And then as a next step, we will have to override. Yeah, so we'll set up the tickets accordingly. And even these overrides, they're kind of optional. And before I implement this, I guess I want to implement the actual delegate to see how far we get with that and how that actually works. Yeah, so that's what I would do. And there's still this requirement for the library, but this stuff we can add at any point. I don't think there is a huge dependency on anything. I think we want to get the main thing, the main idea implemented first, and then, do the grunt work, because at some point it will just be grunt work, especially when it comes to implementing the delegate. But we can try to be smart here and reuse as much code as possible, which is easy as this is just plain Rust code and, nothing special here. All right, I think I'm fine with that. That will totally work. Totally so. And I'm going to say thanks for watching and have a great day.